Good morning, everybody. It's late for me, but it's whatever. Welcome to IB Buddy, Grade 9 Mathematics, Unit 5, Linear Systems, Topic 1, Solving Linear Systems by Graphing. So, first we need to understand what is a linear system. A linear system are two linear lines that intersect at one point, or we'll get into that later. So let's get into intersection. So here we see one diagonal line and one horizontal line. Can you find where they intersect? Here you can see both the x values and y values for both these points are exactly the same on this specific point. 3, 4, 3, 4. So solving means making sure that both those equations have the same x and y value, hence the term solving. So I like to use y equals mx plus b format in linear equations because it tells me more information and also it's way easier to use. So let's get into what it is. So m is the slope. So how fast the linear line changes. So if it goes here, if that's the slope, if it goes like that, that's the slope. Then we have x, which is the x value, and then b, which is the y-intercept, which is the point where the line crosses the y-axis. So now let's get into different types of intersection, which I was talking about. First, which is the most common, is where both two lines intersect at one point. That means there are only one solution, which is just this intersection. Then we have lines that overlap each other. So here the solutions are infinity. There's infinite solutions because the point of intersection is here, 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 here. It's all over here. So that's like infinite solutions. And then there are parallel lines. So two lines are parallel to each other. And as you know with parallel lines, they'll never meet each other. They'll never touch. So if it means that they never touch, there's no point of intersection, meaning that there are zero solutions. Because solutions are basically how many times it intersects. So let's now get into a practice example. So we have y equals 2x plus 1 and y equals negative x plus 4. So to solve by graphing, we graph both these equations and see where they intersect, or if they don't. So let's first graph y equals 2x plus 1. So if you remember, the slope formula is m equals rise over run. So if you see here, this is the slope, m. 2 is m here. So 2 is the slope. So if you turn 2 into a fraction to get rise over 1, that becomes 2 over 1. Can you see the similarities here? Rise is 2, run is 1. So now we do the logical thing, and now we know the slope and how much to go up by and run by. Now we need to see the y-intercept. So this is plus 1. So it would be right over here. This is the y-intercept. Let's just mark that point. Now we see that it goes up by 2 because that's the rise. It rises up by 2. 1, 2. And runs by 1. So 1 right here. So this is 1 point. And then you want to graph 3 or 4 points and then grab a ruler and then draw the line to make it more accurate. I'm on a whiteboard, so I don't have a ruler. This kind of sucks. So here, rises 2, 1, 2, and runs 1, 1, right here. So now you have 3 points. You can use the ruler and draw. I don't have a ruler, so I'm trying the best I can do. Okay. So let me just remove that 2 over 1 here. Okay, so now when you always have a graph, when you sketch a graph, you want to plot the axes. So here, this is the x-axis, so I put x, and this is the y-axis, so I put y. And when you put in a linear equation, you want to make sure that you label this. So this line represents y equals 2x plus 1. So you just put here y equals 2x plus 1. Okay. Now let's graph the other line. This has a negative slope. Negative x essentially just means negative 1x. Okay? So now let's just focus on the number, negative 1. So rise over 1, run. This represented as a fraction is just like over 1. So rise is negative 1, which means it goes down 1. And 1 is just, it goes positive, so it just runs 1. So if we look at the y-intercept here, it's plus 4. So 1, 2, 3, 4. Okay, so we know this is, or let's use a different marker. So this is right here, 4. Now let's go down 1. Rise goes down 1, run 1. So this is 1 point over here. So this is also a point. And then let's go negative 1, go down 1, run 1 here. Okay, now we have 3 points. So we can just like grab our ruler, which I don't have. Wow. Art skills are not great. Okay. Now, I'm pretty sure you can see the point of intersection right over here. And this means that they have one solution, one point of intersection. So now, if the teacher asks you, what is the point of intersection? You want to be able to find the point. So as you can see here, this aligns with 1. So, you know, when you plot points, it's x and then y. So here, the x for this point of intersection is 1. As you can see, it lines up perfectly with 1. So that's 1. And then 3. So y. You see the y value completely is level with 3. The y value of 3. 1, 2, 3. And that's that. So 1, 3. So that is the point of intersection. And then if the teacher asks you how many solutions, obviously these are intersecting only once, because now they're just going off and off. That's never going to intersect again. So you just put solutions 1. Solutions 1. Wow, that's bad. Okay, let's move on to the second example. For our second example, we see we have y equals 3x minus 2 and y equals 3x plus 4. You notice the similarities between these two equations? You see that the slope are the same, but the y-intercepts are different. So when you see that the two slopes are the same, that means they're going to be going up and rise over 1. That's going to be at the same rate. But the only difference is this y-intercept, it intercepts the y here. So it goes like that. While instead of this one is 3x plus 4. So it intercepts the y here. So the only difference is where they're placed. So now that means that there are no real solutions because parallel lines, they can't intersect. So let's just graph it out just to check. But that's a good rule of thumb. So just like quickly get those equations on like a math test. Quickly just say solutions 0. Point of intersection, there is none. So let's just graph it just to let you see. So let's first see the y-intercept, minus 2. So you go minus 2 here. And then the slope is expressed as a fraction as 3 over 1, which means rise is 3. So let's go to negative 2 real quick here. Okay. Now, it rises. Oh, that looks like a 7. Okay. It rises 3. So 1, 2, 3, and runs once. 1. So that's another point. Okay, rise 3, 1, 2, 3, run once. There. Okay. Now with the ruler, graph your points. Wow, that didn't even touch. Okay. Okay. And obviously, label your linear equations. So this represents y equals 3x minus 2. Okay, now let's go on with the second, graphing the second equation, which is y equals 3x plus 4. So we see the slopes are the same, so the same goes for here. That is the rise, and that is the run. So we go with the y-intercept, which is 4 right here. Now, with rise over run, rise 3, 1, 2, 3. And then run once, 1. There. Rise 3, 1, 2, 3. Run once. There. Perfect. So now, we'll just grab a ruler, which I don't have, my imaginary ruler. Wow, that's a very wobbly line. Sorry about that. So as you can see, these are two parallel lines. Parallel lines will never intersect with each other. So that means there are no real solutions. There are no points of intersection. Yeah. Okay, moving on to our hard example. For our third example, which is quite hard, is we have the linear equation 2x minus 3y equals 6 and 3x plus y equals 1. So now we see that this is not in y equals mx plus b format, so we want to make this into y equals mx plus b format. So to do that not simply, we have to isolate y and move all this to the other side and remove the -3 from y. So let's do a little bit of algebra. So we have 2x minus 3y equals 6. So now what we want to do is move this to the other side so we can isolate y. So we have -3y. We put this to the other side, and you subtract by 2x. So then here you subtract by 2x, 6 minus 2x. But that's what I mean. So you subtract here by 2x. That means this 2x minus 2x is 0. So then you subtract here by 2x to make the equation balanced. Now what you do is divide all this by -3. So you divide here by -3. That means you divide all here by -3 to make the equation balanced. So here, this would be y equals, so 6 divided by -3 is -2. -2. And then -2 divided by -3. In IB, we do lots of fractions. So unless your teacher says specifically to make the slope a decimal, we're gonna work with fractions because it's also much easier because we see rise over run. So this would just be negative, and a negative divided just makes a positive. So that'll just be positive 2 over 3x. Now to just rearrange this into y equals mx plus b format, this is mx here and this is b. So let's just move this to the other side to make it look better. Y equals 2 over 3x, and then -2 goes here, right there. All right. So this is our final equation for number 1. So let's just write number 1 for no confusion. All right. So now to graph this, let's just remove all this so we have enough space to write or to draw, to graph y equals 2 over 3x minus 2. All right. So we see first the y-intercept, -2, right over here. Now we want to see rise over run. So this is already rise over run for us. This is already a fraction. So it rises by 2, 1, 2, and then runs by 3, 1, 2, 3, right here. Okay, rises by 2, 1, 2, runs by 3, 1, 2, 3. Yeah, and then grab your ruler, my non-existent ruler, just like that. That is, and make sure to label your equation. So this is y equals 2 over 3x minus 2. Alright, we can just remove this now, because we have it over here. Okay. Now let's graph the second equation. So this one's a little easier. All we have to do is move this to the other side and then rearrange. So here we can just do over here. You subtract here by 3x, and then to make the equation balance, you subtract here by 3x as well. So that would just be y equals 1 minus 3x. Now, to make it into y equals mx plus b format, just move this over here. Y equals -3x plus 1. All right, now rise over run format. This is not a fraction, but to make a fraction, let's do that. Boom, boom. Now we know rise over run. So first, let's see the y-intercepts. So y-intercept is right here at 1. And then the slope is -3, so it goes down by 3. So 1, 2, 3. And then runs by 1. 1 right here. Okay. Alright, I forgot to plot the y-intercept. 1. Okay. Now we want to do it again. -3, 1, 2, 3, because it goes down, and then run by 1. Boom. 1. Just like that. And then let's just do this. Boom. Okay. Don't worry about this. And then obviously label your equation. This is y equals -3x plus 1. Alright. So now we just find the point of intersection, which is right over here. So since my graph is kind of off, let's just say this is 1. So x is equal to 1. So obviously, to plot a point, this is the point of intersection. So first, let's find the x of this point. So this point, the x is 1. So we put 1 here. And then that would be over here. So I would say -1.5. Because this is a -1. And then this is halfway between -1 and 2. So let's just say -1.5. That is your point of intersection. And again, we see that there's only one solution because there's only one point of intersection. So of course, we just write one solution. So this is it for linear systems. If you have any questions, please drop a comment down below or email us and join our Discord server. Follow all our social medias. You know what to do. Thank you for listening. Thank you for watching. And I'll see you guys next time.